All right, let's dive into recurrent neural networks, or RNNs. Now, you've probably heard they're amazing for handling sequential data, right? But the real magic is in their different flavors. Today, we're going to unpack the 4 key architectures, and you'll see how they all build on one really simple, elegant idea.
So, here's our game plan. We'll start with the basic blueprint that ties everything together. Then, we'll walk through each of the 4 main types: one-to-one, one-to-many, many-to-one, and the super versatile many-to-many. Simple as that.
Okay, so before we jump into the different types, we need to get one core idea straight. There's a single, simple rule that separates all of them, and it all comes down to a basic relationship inside the network. And here it is. The big secret? It's all about the input-output structure. Seriously, that's it. How you classify an RNN depends entirely on how much stuff you feed in versus how much stuff it spits out. Remember that, because that's the key to everything we're about to cover.
All right, first up, let's talk about the one-to-one model. This is the most straightforward one, kind of like the classic vanilla version of a neural network. It's our foundation.
And it's exactly what it sounds like. You can see it right here. It's super simple. You put one piece of information in, and you get one piece of information out. A direct, one-to-one relationship. No frills.
So what's this good for? Well, it's perfect for your standard classification tasks. Think about it. You feed the network one chunk of data, and you just need a single answer back. Is this email spam or not? That's a classic yes or no binary classification. One input, one output. Done.
Okay, let's move on. Our next type builds on that simple idea, but it does something really different. Now we're getting into generating whole sequences from just a single starting point.
And you can see what's happening here, right? We've got one input, but it fans out into a whole bunch of outputs. Instead of just one answer, the network is creating an entire sequence for us.
This is where things get really powerful for generative tasks. The network takes that one input, thinks about it for a second, and then uses its own internal memory, what we call its hidden state, to start creating a whole series of outputs. The classic example? Image captioning. You give it a single picture, and boom, it starts writing a sentence to describe it, one word at a time.
All right, now let's completely flip that last idea on its head. What if you have a sequence of inputs, like a whole sentence, but you only need a single output at the end? Well, that's exactly what the many-to-one architecture is for.
With this model, the network is basically listening to a whole series of inputs over time. It's digesting and gathering up all that information from the entire sequence, and only then does it produce one final single output. It waits till the end to speak, you could say.
And this is absolutely perfect for something like sentiment analysis. The model reads an entire movie review or a whole tweet. It processes the full context from beginning to end, and only then does it make a judgment. Thumbs up or thumbs down, positive or negative. It's all about summarizing a whole sequence down to one single classification.
And that brings us to our final type, the most complex and, honestly, the most versatile of the bunch, the many-to-many model. This is where RNNs really show off their power in handling those tricky sequence-to-sequence tasks.
This is the whole shebang, the full sequence-to-sequence model. What's happening is the network takes in an entire input sequence, and in response, it generates a completely new output sequence. You can almost think of it like a conversation happening between 2 different streams of data.
This architecture is the absolute powerhouse behind things like machine translation. It usually works with what's called an encoder-decoder setup. The encoder part reads the input, say a sentence in English, and squishes it down into a meaningful summary. Then, the decoder part takes that summary and generates the output sequence, the same sentence, but now in French. And here's the really cool part. It can be asynchronous. That just means the input and output don't have to be the same length, which is crucial for translation, right?
So there you have it. One-to-one, one-to-many, many-to-one, and many-to-many. To make sure all this sticks, think about this for a second. Based on what we just covered, which one of these architectures would you pick for a job like translating a sentence? I hope this really helped clarify just how flexible and powerful RNNs can be. Thanks so much for tuning in.